We are continuing our work with standard form or equations and other forms, and in the previous 6 problems we practiced converting equations into standard form, and so now we are going to use those same 6 equations that we had previously, and now we are going to convert them into slope-intercept form. So remember that slope-intercept form is y equals mx plus b, where m is our slope and b is our y-intercept. So when we convert these equations into slope-intercept form, our goal in this situation is to get y by itself on the left side of the equation. So when we were working with standard form, we wanted our x and our y term on the same side. So our focus is changing, and so we're going to practice with that. So in this case, we have 3x equals 6y plus 18. So our goal is to get y by itself, and there are a couple of different ways that you can go about this, but I'm going to just look at where my y term is and what I want to remove from that side of the equation and move to the other side. So in this case, I want to remove the addition of 18, so I'm going to subtract 18. And just be careful here that you have 3x minus 18. You can't combine these terms. They're not like terms, so don't try to subtract those. So we have 3x minus 18 equals 6y. We are closer to getting our y by itself, but now we need to undo this multiplication of 6, so we are going to divide by 6. And so I'm going to write my y term first, so y equals, and then 3x divided by 6. So each term in your numerator is divided by that 6. So 3x divided by 6 would give us 1/2 x. And then 18 divided by 6 would give us 3, so 1/2 x minus 3. So now we have an equation in slope-intercept form. So if we have 5y equals negative 4x minus 20, so my y is already isolated on the left side of the equation, so now I just need to undo this multiplication of 5, so I'm going to divide by 5. And I will get y equals, remember that the negative 4x is divided by 5, so if I can't simplify that, then I just write this as negative 4/5 x. And then negative 20 divided by 5 will give us negative 4. So simplify what you can in each of the terms. Okay, next one, negative 2x plus 5y equals 1. So I need to add 2x to both sides. And so I would have 5y equals 2x plus 1. And then I'm going to divide by 5. So y equals 2 divided by 5. I can't simplify that any further, so I'll just write that as 2/5 x plus 1 divided by 5. I can't simplify that any further, so I'll write that as 1/5. So y equals 2/5 x plus 1/5. Okay, I'd like for you to take a moment to try the last 3 on your own. So pause the video now, and then when you are finished, push play to reveal the answers. Hopefully you have taken a moment to write each of the following equations in slope-intercept form. So now I'm going to go through those answers with you. So in this case, you would subtract 4. So y equals 5x minus 4. You can subtract 10. And your steps may be a little bit different on this one, but hopefully we'd end up with the same result. So 5y plus x equals negative 10. And then we have to subtract x. So 5y equals negative x minus 10. Divide by 5. So y equals And be careful that there's a negative 1 here, so that would be a negative 1/5 x, and negative 10 divided by 5 is negative 2. So y equals negative 1/5 x minus 2. And last one, you can also have a variation of how you worked this one out as well. So don't erase yet. Make sure that we agree or disagree on our answers before you start changing your work. So in this case, the easiest way I see to get my y by itself is to undo this addition of 6. So I'm going to subtract 6 from both sides first. And if you chose to take another route, don't undo that yet. You may surprise yourself. So 6x and a negative 8 and a negative 6 is negative 14 equals 2y. And then I'm going to divide by 2. So y equals 6x divided by 2 is 3x, and negative 14 divided by 2 is negative 7. So y equals 3x minus 7. So if you have anything to change on those last three, then make sure you pause the video now and make those changes. Okay, so one of the other things that we're going to do today is, besides just converting equations into standard form or from standard form into slope-intercept form, we are going to look at how to find intercepts. And this can be really helpful when you have an equation in standard form like we do here. So if we have the equation 2x plus y equals 3, we can convert that equation to slope-intercept form, but I want to show you another way where if you're finding your intercepts, that it can also help you graph this equation. So it says to find the x-intercept, let y equal 0. And so what that means is that you can find your x-intercept, or where the equation crosses the x-axis, by plugging in 0 for y, or substituting that value in. So in our equation, 2x plus y equals 3. In for my y, I'm going to substitute 0. So 2x plus 0 equals 3. And so then I would have 2x equals 3 and continue to solve for x. So I would divide both sides by 2. So x equals 3/2. So that means that on our x-axis, that our x-intercept is going to be 3/2, or 1.5. So when we graph this, we're going to see if this is accurate. To find our y-intercept, we are going to let x equal 0. So you can see how these values change. If you're finding your x-intercept, you're eliminating your y term so that you have an x value. When you're finding your y-intercept, you're letting x equal 0. So in this case, if we have the equation 2x plus y equals 3, and we are letting x equal 0, so we are going to substitute in 0 for x, so 2 times 0 plus y equals 3. 2 times 0 is 0, so 0 plus y equals 3. So then y equals 3. So keep in mind here that our y-intercept, so that means that if our x value was 0, our y value is 3. And for our x-intercept, our x value was 3/2, and our y value is 0. So we just practiced converting equations to slope-intercept form. So I'm going to show you why and how this works. So if we were to convert this equation into slope-intercept form, we would subtract 2x from both sides of the equation, and we would have y equals negative 2x plus 3. And so we could graph this equation by recognizing our y-intercept, which is also the same as the y-intercept that we found here. That is not a coincidence. That should be the same. So if you find your y-intercept, this should be your y-intercept here. And then we also have our slope. So on our y-axis, we're going to plot the point at positive 3 and use our slope of negative 2, so going down 2 and over 1, down 2 and over 1, down 2 over 1, make some points on our graph. And whoa, that was supposed to be a line. Let me erase and try that again. So positive 3, going down 2 over 1, down 2 over 1. And let me try a better line, hopefully this time. There we go. There, that's better. Okay, and so then we can go back to what we had before and see, okay, so our y-intercept we found 2 times. We found our y-intercept when we plugged in 0 for x, and we also, when we converted our equation into slope-intercept form, we found our y-intercept to be the same, which was 3, so that's good. They should be the same. And then when we graphed our line using our y-intercept and our slope, we can also see where it crosses our x-axis. And so if we look at where it crosses our x-axis, which is right here, that looks very similar to what we found our x-intercept to be over here. So we found our x-intercept to be 3/2, which is the same as 1.5. Should not be a line like that, I apologize. So 1.5, that's better. And so 1.5, we can see there's a point on our line, so that makes sense. We found our x-intercept, our y-intercept, we graph, and all of those correlate. All right, let's try one more. So when we are trying to find our x-intercept, remember that we are going to let y equal 0. So we can leave our equation the way that it is. So if we have 3x equals 9y plus 18, we are going to substitute 0 in for y. So in our equation, 3x equals, and instead of y, we're going to substitute in 0. So 3x equals 9 times 0 is 0 plus 18. So 3x equals 18. Divide both sides by 3. So x equals 6. So that means our x-intercept is the point 6 and our y value is 0. When we find our y-intercept, we substitute 0 in for x. So in this case, we would have 3 times 0 equals 9y plus 18. 3 times 0 is 0. We want to get y by itself, so we can subtract 18. So negative 18 equals 9y. Divide both sides by 9. So y equals negative 2. So then our y-intercept is the point 0, negative 2. So make sure that when you make the ordered pair, that your x value here is the value that you found x to be, and your y value is 0, and your y-intercept is 0, negative 2. So just be aware of where you plug in those values. So if we were going to write this equation in standard form, so if we have 3x equals 9y plus 18, remember our goal for writing equations in standard form is to get our x and our y term on the same side of the equation. So I would subtract 9y, and I would have 3x minus 9y equals 18. So that would be the equation in standard form. And then if I was going to convert this to slope-intercept form, so we have an equation in standard form we can use, we have this equation that doesn't have a particular form up here, so it doesn't really matter which form you use, so I'll just use the one we just wrote in standard form. So if I have 3x minus 9y equals 18, I am converting this to slope-intercept form, so I would get y by itself by subtracting 3x. So I would have negative 9y equals negative 3x plus 18. Divide both sides by negative 9. So y equals negative 3 divided by negative 9 is a positive 1/3 x, and a positive 18 divided by negative 9 is negative 2. So y equals 1/3 x minus 2. So there are a couple of different ways that you can graph, and this is why it becomes helpful to be aware of all of these different forms. So let's start with our points of 6, 0. So our x-intercept was 6, 0, and our y-intercept was 0, negative 2. Also, we can see that our y-intercept we found to be negative 2. This is not a coincidence. They should be the same if we're doing this correctly. We can also see just by plotting these 2 points, our x-intercept and our y-intercept, that we can create a line. Let's also go down here and look at our equation in slope-intercept form, and it says that our slope is 1/3. So if we were to start at one of the points and go up 1 over 3 and make another point up 1 over 3, we could see that all of those points connect. So we now can recognize that we have many different forms of equations that give us the exact same line. So it's really helpful to be able to find kind of the nicest or easiest way for us to graph given different equations. So for example, if you're given an equation in standard form, it may be easier to just find your intercepts and be able to make your line than converting it to slope-intercept form. If you have an equation in slope-intercept form, it's really easy to just plot your y-intercept and use your slope as opposed to maybe finding the intercepts. So there's some flexibility in how you can get different pieces of information from equations that we have of a line.